Welcome to the brand new video of Forage job simulation series. Today we are going to perform JPMorgan software engineering job simulation. JPMorgan Chase and Co's software engineering job simulation, which includes self-paced learning of 4 to 5 hours, which has no grades and no assessments. This job simulation work as we have to complete their task. After completion of the task, we earn a certificate, which we can add to our resume to stand out from the crowd.
My name is Danny Brennan. I'm a vice president here at JPMorgan Chase, responsible for leading a DevOps team which supports a global payment platform here at the bank. This program is an opportunity to engage in an online virtual internship to explore life as a software engineer here at JPMorgan Chase. The program has been designed to simulate the type of work expected of students during the summer software engineering program and close the gap between what you've learned in the classroom and what you need on the job. This program contains 5 modules that build on each other. It is expected that this program will take you approximately 5 hours to complete. During the experience, you'll be hands-on, building a web application that connects to Apache Kafka for messaging, leverages an H2 database for storing data, and exposes a REST API. Learning these critical skills will help you drive your career forward. When you work at JPMorgan Chase, you're not just working at a global financial institution, but you're working at one of the largest tech companies in the world. Our team of more than 50,000 technologists design, build, and deploy everything from enterprise technology initiatives to big data and mobile solutions, as well as innovations in electronic payments, cybersecurity, machine learning, and cloud development. Our software engineering program offers 2 great opportunities to become part of our team. As a summer intern, you'll spend 10 weeks diving headfirst into our culture and gain hands-on experience creating innovative solutions. You'll work on an agile team along with other interns and experienced software engineers. At the end of the summer, top performers may receive an offer to join us for a full-time role upon graduation. As a full-time software engineer, you'll own projects from requirements through implementation while keeping teams and stakeholders up to speed on progress of what's being developed. You will also have the opportunity to participate in our Force for Good project, where you'll develop real-life technical solutions for social good organizations, learning new skills and collaborating with other JPMorgan Chase technical experts. So what do you say? Let's get started. Take the first step in joining the JPMorgan Chase team.
Task in this program includes 5 tasks. First task is a project setup. Second task is Kafka integration. Third task is H2 integration. Fourth task is REST API integration. And the last one task is a REST API controller. In this job simulation, we learn skills like Java programming, build tools, Spring framework, messaging queuing, SQL database, Spring and REST APIs. Now let's get started. Our task 1 is a project setup.
Hello, my name is Michelle. I'm a software engineer in JPMC's commercial and investment banking line of business. Today, I will be introducing you to your new project. JPMC wants to study the way commercial behavior naturally emerges in closed economic systems. To do this, they're running an experiment in Port Cornus, which is a small fishing community on the Alaskan fringe. The denizens of Port Cornus have consented to conduct all of their local financial transactions through a new system that's being developed called Midas. Since the entire town is part of the experiment, JPMC should be able to collect a relatively complete corpus of economic data regarding the community. This data is anticipated to reveal naturally emerging economic trends, which then can be extrapolated to the broader economic systems JPMC operates within. Your task is to develop the Midas system.
The background information of the task is Midas Core is the main engine of a banking system, built to securely process and record financial transactions in real time. My job is to connect key technologies like Kafka for streaming data, a SQL database for transaction validation, and REST APIs for incentives using Spring Boot for seamless integration. Setting up the project environment and understanding the code bases are my first steps. Before building out these conditions, this hands-on work simulate how professional fintech products are created at companies like JPMorgan. Our task is to fork and clone the Forage Midas GitHub repo containing the Spring Boot scaffold of our teammate prepared. Open this in our IDE that support Maven and Spring. IntelliJ IDE is recommended for this project, but we can also use VS Code. This project requires Java 17, so be aware. Then we have to add required dependencies for Spring Data, JPA, Spring Web, Spring Kafka, H2 and relevant test libraries, running each of the specified version. Finally run task 1 test and submit the output. They provided resources for the task is Maven repository and IntelliJ IDE. You can use this for your task. Here we have to submit our output. I already created a file of output. So here we have to copy paste line by line from the file. Congratulations on completing the project setup task number 1. Task number 2 is Kafka integration.
Hi, I'm Nolan Kinborn, a software engineer in JPMC's corporate investment banking business area. I'll be walking you through task 2. As you know, Midas Core will be responsible for processing, validating, and recording transactions, but these transactions have to come from somewhere. The broader Midas system includes a web front-end, a point-of-sale system, and a mobile application with which users can conduct transactions. The individuals responsible for designing the system architecture decide to completely decouple these components from Midas Core. To this end, they decide to incorporate a message queue to mediate communication between these components. Your task is to integrate this queue with Midas Core.
Background information of this task is Kafka is a reliable message queue that decouples front-end and back-end by buffering messages for asynchronous processing, allowing smooth handling of traffic spikes. It also scales easily by distributing workload across multiple consumers, ensuring efficient transaction management. Our task is to create a Kafka listener in Midas Core that listens to a configured Kafka topic and automatically deserialize incoming transaction messages into Java objects. This integration enables Midas Core to receive transaction data from Kafka seamlessly using Spring Boot's Kafka listener annotation. Task second question is, what list reflects the amount attached to the first 4 transactions received by Midas Core? And the answer is first. Congratulations on completing the Kafka integration task number 2. Our next task is H2 integration.
Hi, I'm Paulina, a software engineer in JPMC's corporate investment banking line of business. I'll be walking you through task 3. With transactions now flowing into the system, it's time to actually do something with them. This next integration will be an SQL database. Every transaction which enters the system will be validated to ensure the sender has a sufficient balance to actually conduct the transaction. And if so, it will be permanently recorded. This is arguably the most important part of Midas Core, since the catalog of transactions it records will be used by the data analytics team to make inferences and draw conclusions about the economic system. The success of the experiment as a whole depends on the robustness of this integration. Good luck.
And the background information of this task is Midas Core uses an SQL database H2 for reliable transaction storage, essentially in finance prioritizing resiliency over speed. H2's in-memory setup simplifies development, and Spring JPA abstraction makes switching to production database easy. Our task here is to Midas Core now integrate with the H2 database to validate and record transactions received via Kafka. Validate transactions where sender and recipient ID are correct and the sender has enough balance are saved. Updating both user balance and invalid ones are ignored. This uses entity relationship in Spring JPA, ensuring accurate transaction history and user balance management. Here we have to submit our task. I already created the answer of this task, so here I am just copying here. Congratulations on completing the H2 integration task number 3. Our next task is REST API integration.
Hi, I'm Dylan, a software engineer in JPMC's Commercial and Investment Bank. I'll be walking you through Task 4. JPMC is particularly interested in how monetary incentives can influence purchasing decisions and whether any emergent behavior develops around them. Therefore, they want to incorporate an incentive system into the Midas project. The idea is that the team conducting the experiment can add money to a transaction if it meets certain criteria. This money comes directly from JPMC and acts as a cash infusion into the relatively closed economic system. JPMC should be able to use the API to experiment with the effects of inflation on prices and purchasing behavior within the community. The criteria might include transactions above a certain size, transactions with a specific subset of users, etc. The criteria will be determined by the team building a REST API to return information on how a given transaction should be incentivized, if at all. Your task is to integrate their API into Midas Core.
And the background information of this is the Incentives API is a separate REST service that Midas Core calls to retrieve incentive details for transaction, enabling modular and independent system development. Our task is to, after validating a transaction, Midas Core posts it to the local incentives APIs, which returns an incentive amount. This incentive is then recorded with the transaction and added to the recipient balance without affecting the senders and enabling the system to reward users intelligently through external service integration. Here we have to submit our task. I already created the answer of this task, so here I am just copying here. Congratulations on completing the REST API integration task number 4. Now we are heading to our last final task. And our final task is REST API controller.
Hi, I'm Mark Jury, a software engineer in JPMC's Corporate and Investment Banking business area, and I'll be walking you through Task 5. Congratulations! The transaction system for Midas is complete, and your team has reviewed and signed off on your work. You've now been selected to pick up additional tasking. The Midas system is required to expose an API to query user balances, but the project hasn't been started yet. This API will be used by a variety of Midas front-ends to surface financial information to users. A simple REST API will be sufficient for the task, and Spring is the perfect framework to make implementing it a breeze. Good luck.
The background information of the task is Midas Core adds a REST endpoint to let users check their current balances, balancing development speed and deployment simplicity. If this feature grows, it can later be split into a separate service for a cleaner architecture. In this task, we have to create a REST API in Midas Core that exposes a GET endpoint on port 33400, which returns the user's current balance as JSON based on a user ID. If the user ID doesn't exist, the API returns a balance of 0, running alongside the existing Kafka listener and requiring the incentives API to be active during the test. Here we have to submit our task. I already created the answer of this task, so here I am just copying here. Congratulations on completing the REST API controller task number 5. Now we completed all the tasks. Congratulations friends, we have completed the JPMorgan software engineering job simulation. Let's celebrate with the like, share and subscribe to my channel. Here is our certificate. If you are watching till here, don't forget to comment for the next job simulation.